Hey, welcome back. So let's go ahead and continue our discussion on polar. So we're going to take a look at some more real calculus type examples. So let R be the region lie between the following circles: x squared plus y squared equals 1 and x squared plus y squared equals 5. And we want to evaluate this integral. Now if we notice right here, this is a volume because I'm looking at the area of my base, which is going to be in polar. We're going to convert this to polar today. And this is my height that I'm going to measure to. Now notice the dA, my area is going to be in polar. Remember that dA right there for polar is r dr d theta. But we still have to convert this surface into polar. So we will have to convert later on x squared plus y to polar. Now remember, we're going to take this, so we'll get to that later. But right now, let's start with the base region. Now the base region, if you notice, is on my xy plane right here. X squared plus y squared is 1. X squared plus y squared is 5. So we need to create a region on the xy plane in polar form. We're going to use polars because we're using circles. Anytime you're using a circle, polars will make it much easier for us. So I can do that pretty easy. My first circle has a radius of 1. My second circle, still at the center, has a radius of square root of 5. So in polar form, I can easily get my formula. My change in radius is going to go from 1, I'm only looking for the shaded part here, is going to go from 1 to square root of 5. My change in theta, well, I'm going to go full circle, so 0 to 2 pi. Now remember, this is as a polar region. Okay? And that's what you want. It's going to make it much easier for us. Now this region, remember, is going to be projected to the surface. So we are going to project the shaded region to the surface, to x squared plus y, to our surface right there, and we want to find the volume. That's what we're looking for. So we're going to take this little bitty circle like this, and I'm going to project it. I always think of it like Thor coming down with his hammer, and all of a sudden, that big old circle in the field, and that beam of light going up into the sky, and Thor's in the center. Alright, so we want to find that volume above this surface to our plane up to the surface. But remember, this is in polar. The x squared plus y squared is not in polar. So the next thing we have to do is just convert x squared plus y to polar. We have some rules. So I can go x squared plus y equals, I know x is r squared cosine squared theta plus y, which is r sine theta. So there's my conversion. And now to get my area, remember my area in polars is the following. It's the area of my base, dA, right? So in polar though, that is r dr d theta. So we're going to have this right in there. So don't forget the r. Now we are going to include our surface in there too. So if I want to get my volume, then I'm going to take the area of my base, which in polar is going to be this r. I'm going to put my function in here, dr d theta. So my r goes from 1 to square root of 5, and theta goes from 0 to 2 pi. What do I multiply that by? My little formula up here. This r squared cosine squared theta plus r sine theta. I didn't give myself much room there. Don't forget this r. That's going to be the one thing that most people forget right there. We don't want to forget that. It's part of our formula right there. And of course, we can distribute that too. It will make it easier to integrate by hand later on. From 0 to root 5, we would get r cubed cosine squared theta plus r squared sine theta dr d theta. And that would be our formula to find the volume. All right, so let's go ahead and look at the next example, number 2. Use polar coordinates to find the volume of the height of the region above by a sphere centered at the origin with a radius of 4. So they're giving us here the height of our surface with a base region created by a circle about the origin with a radius of 2. So here they're telling us about the region that we are going to project in. So here's the region to project. In other words, they're giving us the base for it. So if we look at the base, they tell us it's a circle centered at the origin with a radius of 2. And we're going to project this up to that surface. So I'm going to go now, in the next example, they say write both integrals in rectangular and polar form and compare the difficulty to evaluate. So let's think of rectangular. To get rectangular, I'm going to think change in y. Now my change in y is not so bad. This is a circle, the square root of 4 minus x squared on top, and on bottom by negative square root of 4 minus x squared. So it's going to go from negative square root of 4 minus x squared to positive square root of 4 minus x squared. And the change in x's go from negative 2 to 2. In polar form, let's look at the polar ones. Now in polar, my radius goes from 0 to 2. So my change in radius goes from 0 to 2. My change in theta is going to go from 0 to 2 pi, because we're going to go completely around that circle there. So let's start off by comparing the difficulty. Right now, the base region is a lot more complicated in rectangular than it is in polar. But now we also, since I'm looking for the volume, we also have to look at the heights. In rectangular form, my height is a sphere with radius 4, so my height would be z equals the square root of 16 minus x squared minus y squared in rectangular. In polar, well, this is just a sphere of, in polar, it's a sphere of radius 4. So in polar form, we'd have to look at the equation x squared plus y squared plus z squared equals 16. Well, in polar form, that x squared plus y squared is just r squared. I can solve for z now. Z would equal the square root of 16 minus r squared. And before you ask, yes, we can even do these in cylindrical form too, and that's going to make that rho equals 4, and that's going to be really super easy later on. Okay, so in polar form, this would be my height. So now let's write out our volumes. In rectangular form, my height, square root of 16 minus x squared minus y squared, dy dx, right? My base times my height, and don't forget my bounds, negative square root of 4 minus x squared, square root of 4 minus x squared, negative 2 to 2. That would be in rectangular form. In polar form, same idea, but remember we can have this r times the square root of my height, 16 minus r squared, dr d theta. Don't forget the r. So integrating now, this is going to go from, well, my change in radius, we said goes from 0 to 2, and my change in theta goes from 0 to 2 pi. Now, which one of these would be easier to solve? This one, because you can just use substitution to solve that one right there. All right. We have one last couple bit of notes, so I hope you enjoyed this video. Go on to the next one, and we'll see you all later. Bye-bye.